Welcome everyone to geometry. We want to take a look today at section 17, which is about quadrilaterals. We're going to go ahead and start though with a definition of polygons. So we had seen previously a little bit about polygons, I believe back in chapter 3 or section 3, but here we have a very nice rigorous definition. I would encourage you to pause the video and read the definition that we have here. All right, so hopefully you've taken the opportunity to pause and read this definition. It's nothing too surprising and it's pretty straightforward. So if we want to talk about a polygon, right, we're just talking about a collection of points where they're all given names. So P1, P2, P3, P4, and P5, for example. And then we're just taking those and we're connecting them. So let's see here, I can actually add polygons. This is quite convenient. If we wanted to take a look at this polygon, won't let me select down there. Okay, so I go from here to here, to here, here, here. Excellent. Back where we started. So there's a polygon. Okay, so a polygon is defined by the set of points, and then we're just attaching lines in that particular order. So P1 to P2 to P3 to P4 to P5, and then P5 back to P1. Okay, so that is how a polygon is defined. All right. Of course, the points are the vertices of the polygon, and the line segments joining the vertices are called the sides of the polygon. A diagonal of a polygon is any line that connects two non-adjacent vertices. So for example, if I join P2 to P4, we have ourselves a diagonal. All right. This section will focus on quadrilaterals, as it says here. And for quadrilaterals, we have a lot of theorems that we can state, including congruence conditions. However, those aren't particularly the focus of this section. But it is worth mentioning that there are at least a couple congruence conditions, one of them being side, angle, side, angle, side, as demonstrated below here. If we have congruent side, angle, side, angle, side, side, angle, side, angle, side, then the two quadrilaterals are congruent. Awesome. Another condition would be angle, side, angle, side, angle. However, it's worth noting that side, 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 side is not a congruence condition. It was, right, for triangles, side, side, side was a congruence condition, but for quadrilaterals it is not. For example, if we consider the square, they all have the same length sides, but that's, right, each side is the same length, but that's also a condition for a parallelogram. So we could have something like this. And we're looking at the same shape. If I drew these well, then all of our sides would be the same. But if I call this side length 2 and this side length 2, then we can see that these two things have 4 sides that are congruent, but they themselves are not. Right? We don't have matching angle measures here. All right. In this section, what we want to do is we want to take a look at several theorems, and some of them we will prove and some of them we will not. First, we'll take a look at the collection of theorems that we won't prove, and then we'll follow it up with looking at a theorem and I believe an example. Let's see. No, we'll finish it up with 2 theorems. So we'll split this up into several videos, make them all really short. So that's it for this one, quadrilaterals. If you don't recall well what a quadrilateral is, feel free to refer back to, I believe, sections 3 and 4 and take a look at those topics. I'll see you back in just a minute.